Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wasallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the solutions of P3 variant 32 of November 2018. And for this, I am using the work of an outstanding and one of my best students, Miss Sayyida Aiza Gardezi of class 2021, the Lyceum. All these instructions are very important, especially this one. Give non-exact numerical answers correct to three significant figures or one decimal place in the case of angles in degrees, unless a different level of accuracy is specified in the question. Must follow all these instructions. An important advice: be merciful. Two important tips to solve the paper in a good way. Number one, read questions carefully. Number two, avoid careless mistakes. Question number one, solve this inequality. In order to solve this inequality, we first remove the modulus from both sides. So by squaring on both sides, we can remove the modulus. By expanding these two expansions, we have this result. By bringing everything on left hand side and breaking the middle term, and after taking common, we have got the complete factorized form of the inequality. Since we have greater sign here, so we need to shade these two sides of the curve. The required region is above the origin. So according to these shadings, the solution of this inequality is x greater than 7 upon 5 or x less than minus 1 upon 7. This is the required solution. Question number 2. Showing all necessary working, solve this equation for this domain. We first need to simplify this function with the help of sum of angle formula. The sum of angle formula for sine is sine theta cos 30 minus sine 30 cos theta. This cos theta is here and this 2 sine theta is here. Now cos 30 is root 3 upon 2, whereas sine 30 is half, and this cos theta is here. In fact, this student has simplified this thing. Half cos theta, negative half cos theta plus cos theta makes positive half cos theta. Now you need to bring this sine theta on this side, right hand side, and then sine upon cos will become tan. So this is the simplified form of tan. Since we have to work in according to this thing, tan is positive, so we just need to work in first quadrant. Since this term is positive, so according to this domain, just work in first quadrant. So this is the required answer up to one decimal place, 23.8. This is alpha and this is theta. Now we need to integrate this, and this is the structure of biparts. See, we have product of different functions. So this ln x will be u and the rest will be dv. We always differentiate u to get du. This is du, and we always integrate dv to get v. Now you need to substitute everything carefully in the formula of biparts. This is the formula of biparts. uv minus v du. It's here. This is u, this is v, this is v, and this is du. Now you need to simplify this carefully and this as well. So when you will simplify this, you'll get this thing. By integrating this, we have this thing. And this is the final answer. You can break the LCM if you want, or you can leave your answer here. Hence show this thing. So we just need to apply limits here because this is the same integral. And one important thing, write constant of integration here. Now by applying limits over here, we can get this answer. This is here. When you will apply limits, ignore this C. So this function is here. You need to evaluate these things very carefully. And this is the required answer. You must be good at algebra and logarithms. You can take this screenshot of this solution if you want. Next question. This is the question of index equation. By substitution method, you can solve this question easily. So this EX, you can suppose this as U. So this will become 1 upon U. This is also U plus 1. By cross multiplication, we have this equation. Finally, we have this quadratic equation. So we have two values of EX, one with plus sign and the other one with negative sign. Since exponent ln is invalid for negative values, ln does not exist for negative values, therefore this answer will be invalid. And this is the required answer up to 3 decimal places. Must follow this instruction. X is minus 1.536. Next question, number 5. This is UV. The gradient of the curve is equal to 1 at only one point. When x is a, show that this thing. So with the help of UV rule, UV prime, VU prime, we can easily differentiate this function. So U prime is minus 1, whereas V prime is 1 upon 8 minus x times minus 1. Here is the rule. V U prime, U V prime, plus sign. V U prime plus U V prime. And this minus is here. So this is 1. Gradient is 1 at xa. Make sure you must substitute xa here, here and here. Now you just need to simplify this equation for a. So by taking LCM and after cross multiplication, we have this thing. You need to make this a subject. Here is this a. And you need to replace a by x because we have to prove this equation in the form of x. This is the required equation. Verify by calculation that a lies between this and this. This is so simple. You need to bring everything on left hand side first and then suppose that equation as f of x. When you will bring everything on left hand side, you will get this thing, x minus 8 plus 8 upon ln 8 minus x. You will get this thing. This is the equation. Now you need to suppose this as f of x. This is here. Now you need to put 2.9 and 3.1. One answer is positive and the other answer is negative. When one answer is positive, other is negative, that means f of x changes its sign. According to this situation, f of x changes its sign from positive to negative. Hence, the root of f of x lies between 2.9 and 3.1. You can write this short statement as well. Since f of 2.9 is positive and f of 3.1 is negative, hence shown. And the formal statement is this: since f of x changes its sign from positive to negative, therefore, let me repeat this. Since f of x changes its sign from positive to negative from x 2.9 to x 3.1, therefore, the root of f of x lies between these two values. So you can either give this answer or you can just give this statement. You have the option. Now, the next part. Use an iterative formula. You have to form the iterative formula with the help of this equation. You just need to write n plus 1 here and n here. Use an iterative formula based on the equation in part 1 to determine a correct to 2 decimal places. Give the result of each iteration up to 4 decimal places. So when you will write n plus 1 here and n here, this will be the required iterative formula. The x1 value is 2.9. Now you just need to do iteration. You need to repeat the process till you get a repeated number. Here is the repeated number. So the answer is 3.02. You have to give your answer up to 2 decimal places. I'm writing the iterative formula here. Xn plus 1, 8 minus 8 upon ln 8 minus xn. This is the required iterative formula for this part. Next question, number 6. A certain curve is such that its gradient at a journal point is proportional to this, y square upon x. Meaning dy upon dx is proportional to y square upon x. The curve passes through the points 1, 1 and e and 2. By setting up and solving a differential equation, find the equation of the curve expressing y in terms of x. Number 1, you need to remove this proportional sign of proportionality by k equal k y square upon x. Now you have to do this separable. You need to bring y square here and dx here. Now by integrating this equation, we have this equation. Now you need to substitute this point here to get the value of c. c is minus 1. Now substitute e2 with c minus 1. So k is half. Now by substituting c and k, both this and this into this equation, you will get this answer. 2 upon 2 minus ln x. You must be good at algebra. Next question, number 7. A curve has equation for this domain. Find the exact coordinates of this stationary point. For that, you need to differentiate this curve with respect to x. And this is u upon v rule, which is v u prime u v prime over v square. We have everything. We just need to put everything into this formula. This is here. V u prime minus u v prime v square. Never expand the denominator. Leave the denominator as it is. Just simplify this numerator and equate dy upon dx to 0 because you are working for a stationary point. You just need to multiply this here. Finally, we have this equation. Sign is negative, so it must be in this quadrant according to this domain. So the answer is pi by 6. Alpha is pi by 6. This is alpha, which is pi by 6. But you are working in clockwise direction, so the answer must be minus pi by 6. When you will put minus half here into this equation, you can get the value of y. So minus half is here and here. So your answer is under root 3. This is the required stationary point with respect to this domain. Part 2. Find the value of a. We need to integrate this. This is simple. This is the application of basic formula number 2. This is the function and its differential is cos x. This 3 is extra, so you can write 3 here. The differential of this denominator is cos x. We just need to integrate this with the help of ln. It's here. And this 3 is extra coefficient, so you can write this here. You just need to apply limits and solve this equation for a. The base of ln is e, so when you will remove ln, you will get e power 1 upon 3 on right hand side. Now work for a. This is the value of a up to 3 significant figures. Make sure your calculator must be in radian mode. Next question, number 8. This is of partial fraction. This is the repeated linear factor. So we always write repeated linear factor twice, once with power 1 and once with power 2. The first factor is half, the second factor is 2, and you need to suppose the third factor yourself. Anything which will make the calculation simple. So by substituting half into this equation, you can get the value of a. Then by substituting x2, get the value of c. This student use the comparing the coefficient method. The easiest method is the substitution method. You should use substitution method instead. Let me do that method here. Let x be 0. When you will put x 0, you will get 8 on left hand side of this equation, and since a is 1 bracket 2 b, you are working for b, you are substituting x 0, so you have 2 here, c is minus 2, and this is 1, so b is 3. This is the easiest method. Don't use this comparing the coefficient method. This will waste your time. But if you are good at this method, you may use, but this method is the best way. Make sure you must substitute the values of a, b, c into this equation. Always substitute the values of the constants into original equation to get the required partial fraction. This is f of x. Hence, obtain the expansion of f of x in ascending powers of x up to and including the term in x square. Here you have to use binomial theorem. This is fine. You can expand this directly. You just need to bring this in numerator. Here the problem is you have to take 2 common from this expansion and from this as well. So first bring everything in numerator if you want. You can take common here, or you can take common after bringing things in numerator. You can use any way. So this student brought everything in numerator here, and this is this simple form, simple binomial expansion, because the first term is 1 and the power is -1. The rule is for negative power 1, for negative 1 power, the rule is this: we expand all terms with positive signs. So when power is -1 and we have negative sign, then we expand all terms with positive signs. So 1 plus second term power 1, second term power 2. Make sure you take 2 common carefully from this expansion. Must give this negative power 1 power to 2 as well. Now this will become 3 upon 2, and this is the expansion of 1 minus x upon 2 whole power minus 1. Since power is not minus 1, therefore you have to use factorial form of the theorem here. First take this 2 common and give this negative 2 to power through this 2 as well. And this is the theorem of, factorial form of the theorem. Make sure you simplify this, and this carefully. This is the required binomial expansion. Question number 9. Without using a calculator, express this complex number in this form. So you have to do the rationalization. When you will rationalize this from denominator, you'll get this thing. And this is the final answer. You can suppose this as z if you want. Let this be z. Hence, without using calculator, express this in this form. This is so simple. This r means modulus and this theta means argument. So you need to first work for modulus. Modulus is 2 root 2, and since this complex number is in second quadrant, so its argument must be 3 pi by 4, because this line is y is equal to minus x. This is pi by 4, so this must be 3 pi by 4. Hence this is the required form. You just need to put r here, theta here and here. R is 2 root 2 and theta is 3 pi by 4. This is the trigonometric polar form. Part B. On a sketch of an Argand diagram, shade the region whose points represent complex numbers satisfying both the inequalities, these two inequalities. This is the equation of circle, center 3i and radius 1. Here is the circle, center 3i and radius 1. And this is the horizontal line, x less than equal to 0. Real part of z is less than equal to 0. Find the greatest value of argument z for points in this region, giving your answer in radians correct to 2 decimal places. You need to shade this side of the line. Let me check this. This is real part of z. The real means x. So x means this line. This is the imaginary part of z. Real part of z, meaning x, yeah, exactly. This line means real part of z means x is less than equal to 0. And this is the equation x is equal to 0. Since they are saying x is less than equal to 0, so you need to shade this side. And according to equation of circle, you need to shade this. So this is the required region. Well, this is 90 degree. Because tangent is always perpendicular to radius. This is 1 and this length is 3. Now we need the greatest angle, greatest value of argument z. This is the greatest value of argument z. For that you need to draw a tangent from origin to this circle. So this is the greatest value of argument z. This angle is pi by 2. You just need to find this angle, and With the help of this triangle, you can easily get this angle. This triangle is here. Get this angle by using sine in this triangle. So sine inverse 1 upon 3 will give you this angle. You just need to add pi by 2 into this angle to get this answer. So this is the inequality of circle, and according to this inequality, you need to draw a circle with center 3i and radius 1. This is 3i and radius 1, and according to this inequality, you need to shade inside the circle. Number 2, this is the line x less than equal to 0. This is the line x equals to 0, so you need to shade this part. Less than equal to 0 means this side. So this is the required region. In this triangle, this is the radius 1 and this is the length 3. So you can easily get this angle by using sine in this triangle, and the angle is sine inverse 1 upon 3. This is pi by 2. We need greatest value of argument z. This is the greatest value of argument z. When z is here, then its angle from positive real axis is greatest. Well, this question is not in this syllabus now. I hope this lecture will help you to understand how to solve the questions of P3. An important advice: be kind and be humble. Good luck. And I'm extremely thankful to Miss Sayyida Aiza Gardezi, who helped me to make this lecture. Indeed, she is an outstanding student. May Allah Pak bless her always. Ameen. May Allah Pak give her the best grades. Ameen. Allah Hafiz.